Settle in, dim the lights, and let your breath slow. Tonight we follow a quiet traveller, Three-Eye Atlas, the third confirmed visitor from another star to wander through our skies. First noticed in July 2025 by the Atlas survey, its path is not a loop but a gentle escape curve, proof it comes from far beyond our sun's family. The night begins the way many quiet nights do, screens humming, the soft shuffle of data across a control room, a wind that taps gently at the dome. Somewhere under that dome, a small wide-eyed telescope is sweeping the sky in square after square, stitching the darkness together like a quilt. The stars stay where they should, almost stubbornly still from one frame to the next, while software subtracts last night's sky from tonight's, looking for the faintest hint of something that has changed. Cosmic rays make brief, sharp scratches. Satellites leave bright slashes. Airplanes flare and vanish. Most of it is noise, but then a tiny fuzz of light appears, not a perfect point like a star, and not the straight certainty of a satellite. It moves just enough. Not much, just enough to feel alive. On a monitor, a cluster of numbers turns from grey to pale gold. That colour means the algorithm has noticed something worth a second look. The object has a tail, or maybe it only pretends to, a smudge made by wind blur. A human pair of eyes leans closer. The smudge is there again in the next exposure, and again in the next, separated by a few minutes and a few arc seconds, like footfalls in the snow. The system gives it a temporary label that sounds like gibberish, a string of letters and timestamps, but to the people in the room it means something simple and thrilling. Follow this. A quick check begins, the ritual that separates mirage from message. Is the streak a ghost of the detector? Number, is it a known asteroid? The catalogue is queried. Thousands of orbits are compared. No match fits the track and sky position. Could it be a distant comet waking up, shedding just enough dust to look soft around the edges? Possibly. The pipeline wants more data, so the telescope returns to the same patch of sky, guiding a little more carefully, breathing with the wind. 4 images become 6, 6 become 8, and the little wanderer walks gently across. Then a faint ember against the dark. Now the hush in the room sharpens, not louder, just a little more awake. A message goes out into the night. A minor alert at first, asking other eyes to check. Across the world, different mid-sized telescopes, night on one side, early morning on the other, turn their faces to the same coordinates. The sky is big, but astronomers have a way of making it feel like a shared room. Replies trickle back. Seen? Faint. Cometary appearance likely. Short note is a hand laid carefully on the same fragile thread. With a dozen measurements, someone tries the first orbit fit. The numbers don't want to live on a circle or an ellipse. They keep tugging outward. The eccentricity, how stretched the path is, refuses to settle below 1. It's early, too early to claim anything. Orbital fits can be skittish when a new object is still near the horizon, when the baseline is short and perspectives shift as Earth spins. Everyone knows this, still the suggestion is there, quiet and startling as a deer at the tree line. This path might be unbound. Pre-covery begins, the astronomer's way of time travelling. Databases of last week's and last month's skies are combed for the same point of light. If the object was there before, hiding in plain sight, those earlier positions will stretch the track and calm the math. A handful of candidates pop up, faint dots in crowded starfields. They are checked carefully. Blink, 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 overlaying grids, measuring the way the object pulls away from the fixed lights behind it. When 2 of those old dots line up with tonight's steps, the orbit fit tightens like a lens coming into focus. The curve remains a curve that never closes. Phones vibrate softly. A few quiet cheers happen in private, the way you might smile without showing your teeth. The next messages are more confident. Hyperbolic solution persists. Activity apparent. Words that mean a visitor, a comet breathing, not like the things that live here. The night, meanwhile, keeps being night. Somewhere a kettle clicks. Someone eats a few almonds without looking down. The telescope continues its careful dance, point, expose, read out, slew, while the sky turns on its ancient gears. Another observatory an ocean away confirms the motion. Yet another catches a faint green tint in a longer exposure, a sign, perhaps, of simple molecules fluorescing in sunlight. The object is still only a whisper, far dimmer than anything your eyes could see outdoors, but on screens it is unmistakable now, a fuzz with intention. Formalities follow, even when hearts are racing. Measurements are packaged and sent with precise timestamps and uncertainties. The Minor Planet Center does what it has done for generations. It listens to the sky's reports, checks, cross-checks, and publishes the circular that tells the community, gently but clearly, that something new is walking past our door. A provisional discovery becomes a designation, and the designation becomes a name with a weight of its own. Third, interstellar, Atlas, a simple lineage that ties tonight to 2 earlier surprises and to a million private moments of wonder. News spreads the way twilight does, unevenly at first, then everywhere at once. Amateur observers point their backyard instruments and try their luck. Some write that they caught a faint smear near the same pattern of stars. Some write that clouds had other plans. Professionals line up spectrographs and dream of counting atoms by their colours. A few modelers quietly spin up simulations asking what kind of shove from a distant sun could have sent this traveller our way. What ancient gravitational conversations shaped its long, slow fall toward our light. In the control room, the adrenaline fades into a steadier kind of attention. This is the part no one sees in headlines. The repetition, the patience, turning discovery into knowledge. More exposures, better calibration, careful subtraction of the background, tighter measurements of the object's centre, even though it's not a perfect point. The first orbit solutions are updated with fresh data, each new night trimming the error bars, each fresh fit repeating the same verdict. Not bound, not ours, just visiting. And the human parts of the story keep weaving themselves in. Someone writes the first internal note that starts, "We may be looking at 3I," and pauses for a breath before finishing the sentence. Someone else drafts a gentle explanation for the public, what interstellar means, why a hyperbolic path is the signature of a traveller from away, why it will not linger or return. A third person opens a fresh notebook page and sketches the curve by hand. Sun here, Earth here, the path bending and then lofting back into the dark. Because sometimes the wrist believes before the mind does. It is not a loud miracle. It does not set the horizon on fire or cast new shadows on the ground. It is smaller and somehow more intimate. A whisper caught in the machinery of the night, a faint breath among the stars that we almost missed and did not. The moment you realise what it is, the room around you changes a little. The screens are still the same, the hum of fans, the red lights under the desk, but the story stretching through them is suddenly longer than your lifetime, older than your language. You can feel the distance it has travelled in your chest, a cool wind from a place you'll never see. By dawn, nothing outside knows what happened. Birds sing the same songs. The road up to the observatory smells of dust and pine, but a new line has been added to the long ledger of the sky, and it carries, in its spare letters and numbers, a fullness that will take months to unpack. There will be follow-up campaigns and careful papers, arguments about the meaning of spectra and the shapes of brightness curves. All of that comes later. For now, the beginning is enough. A small telescope swept the dark. A whisper of light stepped across a few frames, and we recognised a guest when it knocked softly at the edge of our vision. Imagine tracing a line across the sky that never comes back to meet itself. That is the path set before our visitor. A one-way thread through the sun's light, a soft bend and then the wide, unending dark. Most comets here are homebodies at heart. They follow closed ovals, long and stretched sometimes, but faithful to return. This one does not. If you could hold its orbit in your hands, you would feel the difference at once. It isn't a loop. It's It's a curve with its ends open, the kind that whispers elsewhere. From night to night, observers plot its steps against the star field and discover that the mathematics refuses to fold. The orbital energy is positive, enough to outrun the sun forever. Its eccentricity sits beyond the boundary that separates the bound from the free. You don't need the numbers to feel it. You can see it in the way the fit improves with every measurement and still resist the temptation to close. Kepler's old rules hum quietly in the background. Equal areas in equal times, a dance carved by gravity alone. But where an ellipse is a vow to return, a hyperbola is a passing bow. The direction of approach tells its own gentle story. It comes in from the star-rich part of the Milky Way, where the sky looks salted with light. On the charts, the inbound path is drawn as a thin arrow that seems to fall towards the sun not as a captive, but as a traveller letting itself be warmed for a moment. The Earth spins, the Earth orbits, and from our moving deck the track appears to curve, but when you transform to the sun's rest frame and smooth away our own motion, the shape clarifies, a clean, open arc, aimed for a single brush with the inner system. As it glides inward, a quiet contest unfolds between speed and pull. Far away, where sunlight is pale and the planets are only thoughts, its motion is almost straight, only slightly tipped by the sun's distant tug. Nearer in, gravity gathers it a little closer, steepening the angle, coaxing a brighter pace. The arc tightens, not into a loop but into a graceful turn. This is gravitational focusing, the sun reaching out with a curved hand, and the visitor allowing itself to be redirected, not captured. The deflection angle depends on how fast it was already moving in the deep, and how close it dares to pass by the furnace at the centre. Fast travellers bend just a little. Slower ones arc more. Either way, the end is the same, an exit line that never crosses back. Its speed is a kind of memory. Even when the sun adds a little dash at closest approach, a residue remains, a hyperbolic excess, the amount by which it still outruns escape. That leftover speed is the signature of a life lived before us. It remembers another system's gravity, another star's long conversations, the distant kick that sent it wandering. Our measurements simply reveal what it already is, unbound. On the sky, the course looks modest, just a few degrees each week across the constellations, but it hides a grand geometry. The path is tilted against the plane of our planets, like a skipping stone arriving from the side of a quiet pond. Most of our worlds keep to a thin disk, a habit learned in the nursery of the early sun. This object ignores the disk. It honours a history elsewhere. That tilt is a blessing. It carries the traveller safely above and below the crowded lanes, past Earth with a comfortable margin, past the realm of the giants where capture is common. There is no threat threaded into this trajectory, only a brief, careful intersection with our daylight. If you mark the moment of closest approach to the sun, the perihelion, and place a tiny flag there, you can divide the journey into two halves. Inbound, the visitor brightens gently, sunlight rousing ices that simmer into a gauzy breath, a coma that faces us like a lantern cupped against the wind. Outbound, the light fades, the plume thins, and the tail continues to point away from the sun like a compass needle that cares only for warmth. Between the two halves, the turn is smooth. No engines, no sound, just the silent arithmetic of mass and distance writing a single S-shaped flourish through the solar system. Orbit fitters talk about frames, heliocentric and barycentric, the sun's perspective versus the whole family's centre of mass. They refine the path in both, nudging uncertainties down as more data arrives. In either frame, the verdict stays the same. The curve does not close. There is a quiet satisfaction in this consistency. The way a held breath releases when two methods agree, the inbound asymptote, its faraway direction before the sun's hand curved it, points to a patch of sky you could cover with your palm. The outbound asymptote, its ultimate heading after the turn, points to another palm-sized patch on the opposite side, a new address in the interstellar night. The sun has not stolen the traveller, it has merely introduced it to a different horizon. Sometimes on a clear evening you can imagine watching the whole drama from far above the poles of the solar system. The planets are beads on wires, their ellipses gleam like bracelets. The visitor arrives from the dark border, scribes its single curve through the bracelets, and leaves, changing almost nothing, leaving almost nothing behind. Almost. There are faint threads of dust it sheds as it warms, breadcrumbs too delicate for most eyes, but enough for wide-field cameras to taste. They will disperse along the outbound leg, thinning into the background until even the cameras lose interest. And yet those crumbs mean something to us. They carry in their chemistry clues about a kitchen we've never visited. For those tracking it from observatories, the practicalities are steady and kind. Predicting its place tomorrow is easier now that the path is clear. Pointing instructions for telescopes can be prepared days ahead, exposure times tuned to a brightness that rises and falls as the phase angle changes. The geometry of sun object Earth shifting the way shadow and shine fall across its tiny icy face. Spectrographs are trained to catch the light scattered by its halo, while careful measurements map how the curve bends, not because we expect a surprise, but because every precise dot laid on that curve is a small hymn to certainty. And through it all, the reassurance remains: this is a passerby. The minimum distance from our planet is generous. The inclination spares us any tight weave through the lanes where gravity can play tricks. The turn around the sun is the only flourish it will make here. It will leave the way it came, quiet, sure, indifferent to our small anxieties, taking with it the story of its origin written not in words but in velocity and direction. If you want to rest with one image, let it be this: the solar system as a warm campfire in a wide dark plain, and Three-Eye Atlas as a traveller stepping briefly into the circle of light. The visitor warms its hands, nods to the company, and then continues on. Our maps are a little better for having seen the footprints. Our understanding is a little deeper for having watched how the traveller approaches, bows and departs. And the path, open and closing serene, reminds us that most of the universe is not a loop, but a road, and that every once in a while, the road brings someone new past our door. At first it looked warm, dusty light leaning toward the ruddier tones you get when sunlight scatters through a cloud of fine grains. Early images were taken through red-sensitive filters while the comet was still far from the sun, its ices barely stirring, and much of what we saw was sunlit dust rather than luminous gas. Photometry from the very first week measured colours that were neutral to slightly blue by comet standards, GR approximately 0.43, RI approximately 0.16. But to the eye, the stacked red filter frames and the dust-dominated halo gave the whole thing a softly red personality. Instruments are honest but also opinionated. What you choose to look with shapes what you think you see. Then September arrived and something changed. During the total lunar eclipse on September 7th, two veteran astrophotographers, Michael Yeager and Gerald Raymond, caught the visitor with a new tint, a distinct emerald wash with a bluish fringe. Their images, made under a wonderfully darkened sky, raced around the community and raised a delicious question: is the comet really turning green? Comets often do this near the sun when certain molecules wake up, but this one had its own twist. Green is cometary shorthand for diatomic carbon, C2, molecules in the coma catching ultraviolet sunlight and re-emitting it in bright green bands. In many comets, that glow simply blooms as the ice warms. But early spectroscopy of Three-Eye Atlas hinted it was unusually poor in carbon chains. Observers detected cyanide CN first and set very low upper limits on C2 compared with CN, placing the object among the most carbon chain depleted comets ever measured. In other words, by the book this traveller shouldn't have been a showy C2 greenie, so the colour shift became a small mystery. More spectra filled in the chemistry. By late August, the Very Large Telescope's high-resolution instruments were seeing CN emission clearly, Along with a surprising forest of neutral nickel lines, Phi remained elusive, as outgassing strengthened on the inbound leg. That CN violet band sits blueward of what most cameras render vividly, so a modest green balance in wideband images could easily be produced by a cocktail of faint gas lines plus reflected dust, especially if the dust grains are small and bright. It's the kind of palette you only notice once the coma crosses a threshold in activity. Part of the apparent drama also comes from how we make pictures. The widely shared cosmic rainbow portrait from Gemini was created by combining sequential exposures through red, green, and blue filters while tracking the comet itself. That makes background stars smear into multicolored streaks, while the comet's own coma looks white in a close-up, its light dominated by reflected sunlight and a blend of weak emissions. The rainbow vibe is real in the art of the image, but not a literal paint box swirling in the coma. As weeks passed and the sun's heat grew, big telescopes kept reporting a broader, more active halo and a lengthening tail. Gemini North captured the newcomer soon after discovery. Gemini South later showed a visibly swelling tail in early September. The coma now clearly gas-rich compared with July. That progression, dusty at the first, gassier later, is exactly what you'd expect as different ices wake in layers. CO and CO2 driving activity far out, then CN from parent molecules, and if present, C2 closer in. 3I Atlas seems to be following the choreography, only with a composition that keeps surprising the spectroscopists. So why did it turn green to some eyes? Fold together three things. First, true chemistry. CN lit up decisively in late August, and even a small, evolving mix of gas emissions can shift the balance of broadband images once the coma brightens. Second, observing geometry. As phase angle and distance change, different parts of the coma and tail dominate, and dust forward scattering can nudge apparent colour. Third, technique. Choices of filters, exposure time, and contrast stretching in stacked frames can emphasize faint green bands that were there all along but below the threshold of notice in July. The eye catches the moment a gradient becomes a glow and calls it a change. Meanwhile, Hubble's view in late July showed a neat teardrop cocoon of dust, a portrait of a nucleus quietly shedding material. As the weeks rolled on, Earth-based cameras watched that cocoon breathe out farther, and news outlets tracked the subtle shift from reddish dust look to surprisingly green as the comet approached its October brush with the sun. None of this made it a naked eye spectacle, but for those following along with telescopes, it felt like watching a flame find its colour. Beneath the aesthetics is the science we came for. A greenish tinge that blooms despite strong carbon chain depletion. Mission tells us that interstellar comets don't all read from the same recipe as ours. It suggests a nucleus assembled under different conditions, perhaps colder, perhaps processed by different radiation histories, where the usual C2 parents are scarce, CN is modest, and trace metals sublimate in odd proportion. Each spectrum is a postcard from that earlier sky. As 3I Atlas rounds the sun and fades, teams will keep teasing chemistry from the light, knowing that in a year the colours will be gone, but the numbers will remain, quiet, precise, and green enough to argue about forever. First, the ground teams tune their instruments, and then the sky answers back. In Hawaii and Chile, mirrors breathe and cool as they swing to fresh coordinates. Exposure scripts lengthen by a few seconds, then a few more, to catch the faint flow of dust now streaming from the visitor. The humming servers remember every photon. When the first Gemini images from the southern desert show a longer, cleaner tail than before, the sense of a story nearing its turning point moves through the control rooms like a hush. The press note says it plainly: the tail is growing as the comet warms, and those of us who love these quiet changes feel our shoulders loosen. We're not watching a spectacle, we're watching a slow arrival of detail. Space telescopes join in with a steadier, colder gaze. In July, Hubble tightened its grip on the nucleus by staring so precisely that background stars smeared into coloured threads. The image was modest and perfect. A teardrop cocoon, dust sloughed from a sunward face and swept back by light. From that geometry alone, you could sense the inward drift would wake deeper layers. Hubble's team turned the picture into a first real-size, bound, small icy active. August brought infrared music. Webb tilted its mirror. Let NIRSPEC take the spectrum apart, and the lines said what the colours could not. Carbon dioxide, water, water ice, carbon monoxide, a whiff of carbonyl sulfide in a mix that startled old comet watchers. The ratio of CO2 to H2O, unusually high, suggested a crust that lets carbon-bearing gases escape more readily than water vapour, or a birthplace where carbon dioxide froze early and stayed rich. It's the kind of answer that's really a doorway. Chemistry that points to conditions that point to a disk around a long-vanished sun. Even newer eyes join the chorus. NASA's Sphere-X, designed to map the sky in near-infrared, reported a wide, bright CO2 coma, hundreds of thousands of kilometres across, like a soft lantern around the nucleus, along with strong water ice absorption signatures. Its numbers helped set upper limits on other gases, and reminded everyone that most of what we see in early images is coma, not core. In a way, that's comforting. It means the comet still holds secrets we haven't warmed out of it yet. As instruments around Earth refine the picture, a second network, machines already circling other worlds, gets ready to look across the lanes. Mars will have the first good vantage. Around October the 3rd, while the comet passes about 30 million kilometres from the red planet, ESA plans to pivot Mars Express and the ExoMars Trace gas orbiter toward the visitor. Their cameras, HRSC and CASSIS, won't resolve the nucleus. It will span less than a pixel at that distance. But their spectrometers, OMEGA, SPICAM and NOMAD, may taste the coma and tail, catching volatiles in a geometry we can't get from Earth. It's a long shot conducted with quiet discipline, and that's exactly the point. A single extra angle can turn a guess into a measurement. Closer to the Sun, the old Sentinel SOHO will see the comet drift through its coronagraph fields, though it will almost surely be too faint to register against the glare. We love SOHO for the fireworks of sungrazers. This wanderer is too dignified for that. The plan is simply to watch the backdrop, confirm the nothing, and let the other instruments do the tasting. Farther out, at Jupiter's doorstep, another set of eyes is being lined up. ESA's JUI-CE spacecraft, now running hot and careful on the far side of the sword Saturn, will try in November to catch the comet in a more vigorous state using cameras, spectrometers, even a particle sensor that can feel dust whisper past. There's a romance to it. One visitor from the outer dark watching another slip through. But the pragmatics are tricky. JUICE is using its big antenna as a sunshield and can only dribble data home on its smaller radio. The geometry is bad for downlink. Patience will be required. The team expects those packets to reach Earth early in 2026. There is even talk of coordinating ultraviolet looks with NASA's Europa Clipper, twin spectrographs peering from different longitudes into the same pale plume. Even if neither image is pretty, the spectra could be beautifully plain-spoken. Between these far-flung outposts, time and geometry do their quiet work. From Earth, the comet slides into solar glare in late September, hides through perihelion, then steps back out of the light in late November, higher and easier for evening telescopes, better place for long, forgiving exposures. The best amateur images will likely come then. A clean tail, a rounder coma, a profile lit from the side. What matters for the science is the cadence. You want spectra on the way in, at the turn and on the way out. You want polarimetry before and after. You want the same filters used by the same instruments to keep the comparisons honest. The plan isn't flashy. It's a metronome. The calendar itself has a heartbeat. The turn around the Sun comes on October the 29th, 2025, midday by universal time in the current solutions, at roughly 1.36 to 1.4 AU, just inside Mars's orbit. The nearest Earth gets is around December 19th, and even then we stand a comfortable 1.8 astronomical units away, with the sun sitting between us for part of that stretch. None of this makes a backyard show, and that's all right. It makes a clean experiment, a passerby with room to breathe. Watching from many perches is not overkill. It's how you turn a quick hello into a story with depth. Hubble's dust cocoon sets the scene. Webb spectrum gives the cast of characters, molecules with histories tucked inside them. Sphere-X colours in the wider halo. Gemini's tail growth marks the tempo. Mars's orbiters, if fortune and brightness cooperate, will add a side-on view of the gas, and JUICE will listen from the giant's neighbourhood as the visitor begins to cool. Each dataset is a small candle. Together they make a room, and in that light we can read a little more of where this traveller came from, and what kinds of kitchens the galaxy keeps for making comets we've never known. In the end, the elegance of the campaign is its humility. No flyby, no fireworks, no dramatic pivot in mid-course, just many eyes, well placed, sharing what they see. A comet from another sun drifts through our circle of light. The instruments take turns, the data pile up like snow. Months from now, when the visitor is already dim and outward bound, the papers will come, numbers, ratios, curves, and the romance will be pressed into something denser, more durable. For now, we're content to know that in observatories on Earth and in small cabins orbiting other worlds, people have remembered to look up together. And that too is part of the story. It speaks in the language of spectra and light curves, but the message is simple. Not all soballs are made alike. By tasting the glow of its coma, we learn that this traveller's pantry isn't arranged like most of the comets we grew up with. The blend of gases that wake up as sunlight warms it, how quickly they rise, which ones come first, which ones lag, acts like a fingerprint from its birthplace. If carbon dioxide stirs early and strongly, you picture a nursery so cold that CO2 froze readily. If carbon monoxide remains stubbornly abundant closer to the sun than you'd expect, you imagine layers that were laid down under different pressures and radiation than the layers in our local family. Even the dust tells stories, grain sizes, how they scatter light, whether they clump or drift apart. Each is a clue about the freezer it came from and the long, slow processing it endured between stars. Set beside the first two interstellar visitors, the lesson sharpens. One arrived with no apparent coma at all, and a puzzling non-gravitational nudge, as if outgassing hid in a way we barely understood, or something else was at play. Another swept in as a bold, textbook comet, but with chemistry tilted toward carbon-bearing volatiles unlike the garden variety mixes near our sun. And now this one, a quieter voice, but again the ratios refuse to match our expectations. 3 postcards, 3 handwritings. We're learning that the galaxy cooks small icy bodies with a fussy chef's variety. Different temperatures, different spice racks, different ovens. There's no single recipe called comet. Size matters because size is survival written in kilometers. A modest nucleus can shed its skin quickly near sunlight. A larger one can weather a passage and keep its ancient layers intact. Bracketing the bulk, whether a few hundred meters or several kilometers, changes how we interpret everything else. How forcefully sunlight can spin it, how much dust can be lofted before the crust slumps, how likely some is to fragment, and how long such bodies can wander the interstellar deep without crumbling into a ghost of grains. Each night of careful photometry trims the uncertainty and moves that bracket inward, turning awe into measurement. What truly delights the theorists, though, is what these wanderers might do away from our gaze. Imagine a newborn star ringed by a cold, dusty disk. Most models ask that dust collide softly for ages, building pebbles, then boulders, then honest planetesimals. But there's a more mischievous possibility. The disk could steal a sturdy interstellar seed and then let material snowball around it. A captured traveller becomes the kernel of a world, especially in massive disks where gravity and gas drag make capture easier. If true, then visitors like this aren't just messengers, they're midwives. They wander until a young star says stay, and around them a planet begins to take shape. Even if none are captured, their flybys still stir the pot. Passing through the outskirts of a disk, a visitor can share dust, trade molecules, leave trails of complex organics that younger worlds later sweep up. The solar system, too, is not immune to gentle gifts. A thin drizzle of interstellar dust filters in every day, and objects like this one remind us that sometimes the donors aren't anonymous grains but whole bodies, carrying layered histories in ice and stone. Their chemistry, how depleted or rich they are in certain chains, which metals peel off as vapour, sets the priors in our equations for habitability. How much carbon is delivered, how quickly water arrives, which prebiotic molecules can survive the long cold. There's also the quiet power of statistics. A single oddball invites poetry. A small population begins to write prose. The first time we saw one, we argued about what it meant. The second time, and we argued more cleverly. The third time, patterns started to appear. Where in the sky these things tend to arrive, how fast they usually coast, how bright they get, which molecules wake first. With each new member of the family, the taxonomy grows. Cumulus drifters, volatile-rich sprinters, dust-heavy bloomers, carbon chain-shy minimalists. Soon the labels will be tied to models of disks, cold outer shells, irradiated skins, shock-processed eddies, chemistry set by the fickle placement of frost lines. The romance will remain, but it will stand on numbers. What makes this particular wanderer so useful is the choir watching it. Big mirrors on high mountains watch the dust change texture day by day. Space telescopes peel the spectrum into barcodes and weigh the gases by their lines. All-sky surveys keep the cadence honest, catching brightness swings we would miss if we only stared now and then. If we are lucky, even distant spacecraft will glance across the lanes and see the coma from the side, tasting the same vapour in a geometry impossible from Earth. No single image is dramatic. Together they are decisive. They give us production rates inbound and outbound, not just snapshots at the peak. They let us test whether the crust evolves, whether jets open and close, whether the colour phase shifts with sunward angle, whether the dust grain sizes skew as the skin erodes. Under the microscope of time you start to see subtleties. Perhaps a nickel line brightens as the visitor warms, hinting at trace metals liberated from dark sun-baked organics. Perhaps the CN band leads the dance while the expected carbon chains stay shy, telling of a birthplace poor in those particular parents. Perhaps the polarization of scattered light shifts as fresh dust replaces weathered grains, a sign that layers are being skimmed clean. Each faint, careful clue pulls at a thread that runs back to a cold shelf around a distant star, to seasons this object knew long before our sun existed. And then there's the human part, the one that never makes it into the math, but somehow keeps the math alive. The way teams coordinate nights like a metronome, same filters, same exposure schemes, same cadence, so that when the story changes, we can be sure it isn't the instrument singing in different keys. The way amateurs with backyard telescopes add the grace notes, long integrations that reveal faint feathered tails, lucky nights that stitch a dozen exposures into a time-lapse of breath. The way a student new to the dance measures a coma profile at 3 in the morning and realises, with a start, that the curve on their screen is older than language. All of it adds up to a quiet revolution. Interstellar objects were once a thought experiment. Oh, what if? At the end of a textbook chapter. Now they're a field. We have workflows ready, instruments tuned, software primed to flag the soft motion that marks an unbound arc. We don't just gasp when a traveller appears, we lay down a runway of observations that turns a fleeting hello into durable knowledge. With each visitor, the galaxy's habits come into focus. Not a single way to build comets or small worlds, but a wide spectrum set by environment and chance and time. The traveller will round the sun and dim. Its tail will lengthen and thin, then fray into the background. The spectra will quiet, the lines folding back into a continuum of sunlight on dust. But the numbers will remain. the exact shape of the light curve, the chemistry ladder climbed on approach and descended on retreat, the final tally of dust and gas. Those are the fingerprints it leaves on our understanding that planetary recipes vary wildly, that captured seeds may jumpstart worlds, that the Milky Way is busy making and unmaking tiny sturdy things and sending them to knock briefly at other doors. And maybe the softest lesson is this: the universe is generous with wonder if you meet it with patience. We could not stop this guess for questions, but we listened in 100 careful ways and found that listening is enough to build a map, not of places, but of possibilities. Now let's bank the fire and finish our watch. The sky is still wide, the instruments still warm. Our traveller is already drifting back toward the quiet, carrying its secret kitchen in layers of ice and dust. We'll close the notebooks, label the plots, and let the data cool into clarity. Tomorrow or next year, another faint knock will arrive at the edge of vision. We'll sweep the darkness, find the tiny motion, and begin again. A shared breath across the world, a curve that does not close, and a story that widens our circle of light. Close your eyes and keep that picture. A campfire of planets, a gentle visitor stepping into the glow, warming invisible hands and moving on without haste. We passed the cup, compared the sketches, and learned that our small circle reaches farther than we guessed. As the ember fades on the horizon, let your breathing match the slow rhythm of the sky. There will be new frames to stack, new spectra to smooth, and someday soon, another messenger from away. Until then, rest. The road between the stars is long, and tonight we've listened well.